So we're doing antiderivative still, and or indefinite integral as it's called. And we're going to do the antiderivative of cosine x plus 3. So now, all we want to do is just write it with integrand on it. Then with our integration rules, we just want to write cosine x plus the integral of 3 sine x. Then that's still not quite enough work. We're going to write cosine x plus 3 times the sine of x. Now we're ready to integrate these, or take the antiderivative. So the antiderivative of cosine x is sine x plus 3 times the antiderivative of sine x is negative cosine x. And all of this is plus c. It's going to equal sine x plus, or we won't write plus, we'll go negative 3 cosine x plus c. And that's our antiderivative. So now if we go back and take the derivative of this, whole thing, the derivative of sine x is cosine x and then it's going to be the derivative of cosine x is going to be negative sine x. It's going to be negative 3 sine x plus, we won't say plus c because if we take the derivative of a constant, it's just 0. So then we're going to distribute this negative, and that's going to turn a negative times a negative, which equals a positive. So it's going to be plus 3 sine of x. And that's just our original function. So pretty much, you could take an antiderivative of a function, or the indefinite integral of a function, get your answer, and then you can verify that answer using, just by taking the derivative of the antiderivative you got. And you'll know you did it right because you would get the right derivative at the end, or your original function at the end. And that's a good way to verify your work, and even just, when you're doing a test, maybe in your calculus class, just to show the professor that you understand that they undo each other pretty much. And that's something that, that's one of the key aspects of antiderivatives or indefinite integrals. They connect to each other. So now we're going to do 5e to the x plus x squared. So we're just going to write that integral notation. Now we're just going to separate them using our antiderivatives or indefinite integral laws. And it's still not quite enough. We're going to drag the 5 out front. And just rewrite the integral of x squared, or the antiderivative of x squared. So, I'm sure you went through derivatives already. So if you took the derivative of e to the x just equals e to the x, right? And the same thing applies here. So it's going to be 5 times e to the x plus, we're going to use we're going to use our power rule equation here. So it's going to be x cubed all over 3. And it's going to be plus c because we have an indefinite integral. So this is just going to equal 5e to the x plus x cubed all over 3 plus c. And that's our antiderivative. So then if we take the derivative of that, it's just going to give us the derivative of 5e to the x, just 5e to the x. And then if you take the derivative of x cubed all over 3, you know you're going to drag this out front, minus 1, which is going to be 3x squared all over 3. 3's are going to cancel out. So what you're left with is, I'll put the answer over here, is 5e to the x plus x squared. And it's exactly your original function. And that's one of the cool things about derivatives and antiderivatives, or speaking integration-wise, indefinite integrals. And the reason why we didn't really include this plus c on our, when we took the derivative of it, is because you gotta remember the derivative of any constant is just 0, so you'd be plus 0 here, which is just still the same thing.